Hey, welcome to this video on algebra, working with algebra tiles, introduction to algebra tiles. So, what you see on the screen, you see different symbols that represent tiles. We'll call them algebra tiles. So, for example, over here, I'm moving on the screen. This is a 1 unit. So 1 unit, so this would represent a number 1. And when we add them together, that will be a very straightforward case for you. You would see that there will be, for example, 3 in total, right? So we can write that by using a pen and say 3 units right here. The next tile that is shown on the screen, we call it an X tile. So that X tile can be added to another X tile because they represent the same type of object. So we'll call them like terms. And by the same token, you see a different tile called Y tile. And again, for every tile of one kind, we can continue adding as many tiles as we wish because they are considered to be like terms. So moving back, 2x tiles would be represented on paper as 2 times x. 3y tiles would be represented as 3y. Already. So let's move to the next page. The next page shows tiles that are rectangular or square. So what is meant by that? X square tile, if you can imagine, was obtained by a product of 1x tile multiplied by 1 y tile. So I repeat, x tile multiplied by itself produces x squared tile. So using this analogy, you can definitely agree that multiplying 1 y tile with another y tile, you will create an area that is equal to y squared. So y times y is equal to y squared. So where that exponent square is coming from, please note, you may be aware already that y is to the power of 1. The next y that you multiply is to the power of 1. So you add exponents because the base is the same. So y times y is y to exponent 1 plus 1, which is y squared. And the next tile that we may or we perhaps will be using in our exercises with algebra tiles could be a tile that is made of 1x tile, which is multiplied by 1y tile. Please note that in order for this to take place, you would have to have this side equal to y length, okay? Or by the same token, this side of x should be equal to that side. So why don't we do that? Then we have to change them around and say perhaps we need to do the following. We can bring x tile which match this length and the y tile which would match this width. So multiplying x and y gives just xy area. I hope this makes sense. So the next slide that we'll move over to would represent opposite. So for every number Like number 1, there is a negative 1. If you think of positive 2, there must be a negative 2. So every number has its own opposite. Same for tiles. If we use the red square, which represents positive 1, so the white square would be representing negative 1. So this is just a convention that we'll follow here. So the color scheme, it doesn't really matter. But for any positive tile, there must be one opposite tile. And what is the significance of that? Please note, when you add 1 and negative 1, you get 0. You add 2 and negative 2, you result with 0. So whenever you add opposite, whether that works with tiles or with numbers, the 0 principle would apply. So x tile add negative x tile would give us 0, which means no tile will have representation as 0 tile. Similarly, y and negative y, also x squared and its opposite negative x squared, and so on. So I hope you understand the 0 principle. I hope you now will follow what we call by algebra tiles. Whether we add like terms, we then group them because they are exactly of the same shape, the same size, and the same color. And in the next video, we will discuss how to add polynomials using algebra tiles, and also how to multiply monomials by binomials. Thanks for watching this video, and I see you in the next video soon.